Physical science classes, we are now starting our last unit of the quarter. So we just in unit 5 covered motion, which is how things move and how fast they move and how they accelerate and how far they go and how long it takes. We're now going to take time and explore how it is those things have that motion. So what this chapter is all about is Newton's laws of motion, which I'm sure you guys have introduced before. But really we're going to get into the forces that cause those things to move. So we have 10 days left in the quarter, and it just so happens we have 10 different days of little videos and quizzes that we'll have. So what we're going to start off with today is just an introduction to forces in motion and how they exist and work in the world. So I think you guys kind of already have a pretty good idea of this, but a force is defined as any action that can change the motion of an object. Oftentimes it's going to be a push or a pull. I have my mower and I push it and that causes it to move. I have a wagon with rocks in my backyard, and when I pull it and apply a force to it, that makes it move. That's usually what we associate that with. It is a vector, and I know we don't really know what that means, but what it really means is we don't just have a force, we also have to have a direction with that force. So it has both a magnitude and a direction. It's not just I applied a force of 10 newtons, it's I push the cart with the force of 10 newtons to the right. As we get into this chapter and look at the motion of things, the direction that we apply that force is very, very important. Just so you guys are aware, you've probably heard of this too, but this little n here stands for newtons, and a newton is how we measure force, and 1 newton is the force it takes to accelerate 1 kilogram, which is, a couple pounds, accelerate it 1 meter per second squared. So that's how we'll measure force. Just a little bit of background, forces can act in 2 different ways. They can act through contact of an object or at a distance. So we've already hit these 2 examples, but if I'm going to push my mower, I have to contact it. If I'm going to stop a ball from moving, I have to catch it. It's the physical contact that applies the force to stop that ball from moving. But we also have something called a force that acts at a distance, or a field force. And a great example, that's gravity. If I take my phone here and I drop it, nothing's touching it, but I know that a force is being applied to it because it falls to the ground. That field force is called the field of gravity. Likewise, magnets are the same way. They can make an object move like a metal coin without touching it because of their magnetic field. So those are 2 things you'll see if you go later into physics. Just a little bit more background here. When we look at the motion of objects and those forces, one of the key things we need to understand is what's called a net force. So whenever there is a net force acting on an object, the object will accelerate in that direction. If there's a net force to the right, the object will accelerate to the right. And I think you guys kind of know, if we look at somebody's net worth, we add up all their debt and all of what they have, and we kind of add it all up, and that's exactly what net force is. It's when we combine all the forces, the left, the right, the up, the down, and what the net is the overall one that wins the tug of war the most. So just a couple examples we'll look at here. This little blue block, maybe somebody's pulling it to the right 5 newtons and somebody's pulling to the left 5 newtons. This would have no net force because the one to the right and the one to the left are going to cancel out and have a net force of 0. So we call this right here an example of balanced forces. This one, on the other hand, we can see that the up and the downs cancel each other out. But then somebody's pulling the box to the right with 67 newtons. Somebody's pulling the box to the left with 12 newtons. So you can see the little work up here. There is a net force. This tug of war is not equal. So this box would move to the right. I think it's backwards on my camera. To the right because there's a bigger force pulling it to the right. So just some terminology you need to get used to. The example here, where 5 and 5 cancel out, is called a balance force because the net force is 0 because they cancel each other out. This example does have a net force to the right, and since they're not canceling each other out, this is an example of unbalanced forces. Just a kind of few more things we'll hit here. So balanced forces do not change motion. If we push on this box and push on this box with equal forces, the box won't move. This physics book right here, it sits on the table because the force of gravity and the force of the table pushing it up are equal, so it's a balanced force, so the book doesn't move. I can't tell how much you see on this little picture here, but since there's air resistance pushing back on the skater and he has that force pushing forward, he's going to keep moving at the same exact speed. He's not going to slow down or speed up because the forces are balanced. Likewise, I think you guys probably really get the hang of this, but unbalanced forces don't cancel out and they'll make things accelerate. This tug of war right here, it would be obvious that the whole group is going to accelerate to the side with 400 because that's a greater force and there's going to be a net force. When a rocket ship lifts up, the force upward has to be bigger than gravity downwards. Otherwise, the rocket would never lift up off the ground. So that's another example of unbalanced forces. You guys will get the hang of this fast, but when you find net force, you're just adding it up. And sometimes we think about left as the negative direction. So if we look at the first example here, I pull the box with 40 newtons to the right, you pull the box with 10 newtons to the left. The net force is going to be 30 newtons to the right because 10 will cancel out 10 of that 40, and what's left is going to be 30 newtons to the right, so the box would move to the right. This example here, B, is an example of balanced forces because 18 up and 18 down cancel out, and 10 to the left and 10 to the right cancel out, so there's no net force, so that box will just stay at rest. The last example, C here, 10 to the left and 10 to the right are going to cancel out, but there's no upward force to cancel out the downward force, so the net force would be 18 newtons in the downward direction, which would mean that that object would speed up as it falls down. Last but not least, we hit newtons. That's how we measure force. I already had that on a different slide. So newtons are how we measure force. It is named after Sir Isaac Newton. Good luck on quiz 1.